of computer architecture course, and today we are going to cover the various aspects of storage systems. So as you know that storage system plays a very vital and important role in computing, and every platform of computing requires efficient storage systems. Either it has been a handy device or a large array of supercomputers. They require the efficient storage systems. Without that, we cannot have a thought of working with computers. So this sessions, we are going to have a detailed discussions on the various types of storage devices. We'll also discuss what are the criteria that access the performance of storage systems, and we'll discuss about the rate models, right? So the learning objectives are, at the end of this unit, you'll be able to define the storage systems. You'll be able to describe the various types of storage devices, the process of connection with IO device to CPU or memory, and we'll discuss the reliability, availability, and dependability of storage systems. In a very brief, we'll talk about the disk architectures and the rate model, and we'll discuss on the input-output performance measures. So let me begin with a question to you all. The question is storage an issue nowadays? Is storage an issue nowadays? You just reply to yourself. Okay, my question is storage an issue nowadays? So you might heard about that when people started working with a computer system of few MBs, okay, where the hard drive was of few MBs, or otherwise the hard disk was of 1 GB, right? So you may have thought of that kind of things just 10 years, 15 years before, when the computer systems, it in a large level, it introduced in our country itself. So we were hunting for storage. People used to start floppy disk. And can you imagine what was the size of floppy disk? It was 3.14 MB. Okay, let me write this. It was 3.4 MB. And the floppy disk was a component like this. Okay, the size is too bigger with compared to the pen drive that you have nowadays. So for 3.14 MB, which is a portable device, floppy disk, we used to say it is FD, right? So you can store up to 3.14 MB, and max to max you can have 1 GB hard disk. So you can imagine. So in that time, storage was an issue, right? If you want to download or if you want to port some software or some data from location A to location B, you have this kind of thing, floppy disk. And they were not reliable. They were very exposed to failure also. You copy the data in a floppy disk, and in the second system, it's not going to open. The file, has been corrupted or whatsoever. So it's not portable, right? It is portable, but it's not going to be very reliable. So that was an issue when we started working with computers. Even I have been a part of that era also, when I started working with floppy disk, and when I was doing my undergraduate project. So I was not able to copy the contents in floppy disk, and we just have gone through 3 floppy disks for that, and later on we realized that none of the floppy disks was working properly to demonstrate in our final terms exams. So this was a major issue earlier, but nowadays, can you thought about this? Storage is available wherever you want. Either it is available in terms of different levels of secondary storage. It's available in terms of server, in terms of Google Drives, in terms of cloud system, whatsoever example you wish to be, you can take. So even if you are not able to store in your own PC, you may have the cloud structure. You can store, and up to that, if you can just see the Google Drive system, 15 GB they're offering you. Okay, Don't worry about the internal component that you have. And if you can just compare with that floppy disk and pen drive, so today you have in your pockets 4 GB, 8 GB, 16 GB, 32 GB. Okay, so see the beauty of working with the storage, how the things has drastically changes, right? No one talk about floppy disk nowadays. So the thing is that there has been a lot of changes in terms of storage, and every change comes to a user friendly, okay, comes to an forum, comes to a system where the things has been massively available in terms of storage. So storage, students, I think it's not an issue. So can you think about that? What is an issue nowadays? If storage is an issue, I will say no, it's not an issue. What is the main point? What is the main issue? What is the main target that you will hunt for today? So the issue is, it may possible that you may be agree with me that the issue is retrieval. Is retrieval an issue? Lots of data, you have lots of data everywhere in terms of server, in terms of different workstations, in terms of clouds, but the major issue is that how to retrieve it properly, how to retrieve it efficiently, how to retrieve it timely. And retrieval, I'm not talking about the database retrieval, okay, I'm just talking about retrieval in terms of the user responses, the user queries, in terms of writing free flow queries, free text queries, unstructured queries, semi-structured queries, all these things. So I hope you got the point that retrieval is being very important terminology. Now, but again, the retrieval is reciprocal to storage. Okay, if suppose I am not able to fetch the data where it is, right? So then definitely the entire things get false, because retrieval ultimately depends on the storage itself. So that's why storage still being a very important part of the computer system. Although the size, I can just write the size of storage is not an issue nowadays, but it's going to be matter for the retrieval purpose. So let us see, storage. If you can refer a general Google search in terms of storage systems, you will have lots of definition. You will have lots of analogies also, because at the very invention, when we started working with not only computers, with different type of element, the first thing is that how to store it properly and how to retrieve it. And there have been bunch of solutions for this. Let us see, as per our contents, what is storage for computers. And I just want to make it very clear that you have two major storage part. First is the primary. Okay, first is the primary memory. And the primary memory, we understand that it is RAM, ROM, extra, okay, which is volatile. And the second that we are going to deal is the secondary memory. Secondary is non-volatile. Okay, it means either you are going to switch off your powers, it's still the data is going to be reside. That is secondary memory. And there are very example like hard disk, you have pen drive, okay, or magnetic tape, CDs, and all that. They're example of secondary. So when we talk about storage system, so definitely we are going to talk about the secondary memory, right? Now it is defined as a device which has the capability to store data, right? Disk and tape drives are considered as storage devices. So that is storage, which means stored data. Now storage is considered as the place in computer where the data is placed in visual form in order to get access by a processor, right? We have talked so much about that when we are going through the session of memory system, the primary memory system. We have seen how it is organized in terms of sequential, random, how paging can be done, how we can have the holes concept. Lot of things we have discussed earlier, but now we'll discuss in terms of this the secondary storage. Now, storage, which can also be called as computer data storage memory, refer to constituents of computer recording media and devices that preserve digital data utilized for calculating for a period. So this definition is more specific with reference to the computer system, because storage being not a word related to only systems. Okay, it can be applicable in all the terminologies, all the stations. So as far as the computer system is concerned, I think this three definitions that may be incorporated, and again I am requesting that we are just going to brief about the secondary storage. So very simple part, store data when computer is off, right? When there is no power, how the data is going to be stored. So there are two processes. First is writing data and second is reading of data. To make it more clear, let me have a mass storage over here. So this I can define as the secondary storage. This is storage as secondary. And when user works, so user works with the primary storage. Okay, that is the primary storage, primary memory, right? So if suppose user is asking anything, the user wants that what is the balance of my account. So it means that everything is going to be stored in this hard disk, right? In different terminologies that we'll discuss. Suppose if there's a value A and A is the account number of this person, so this value will go over here, right? So this is known as read operation, read. And when he updates something, suppose the balance was 500 and now he wants to update to 1000 rupees. So this, when it's going to be update, it is known as write operation. So do understand students, although all of you are aware about read and write, but in terms of memory also, read means transferring of data from the secondary storage to the primary storage. So that's why it's accessible to user, and the writing means transferring of data from the primary to secondary. You sometimes you understand na, in terms of save. So what is save operation? Save means that you are just storing, you are transferring the value from primary to secondary. When the power gets off, when the computer is off, this is not going to save anything. This is going to be vanish away. But the entire data which has been stored over here will be there, will be procured, right? So that is the storage part. All of you understand the basics. Now storage terms. So media is the material storing data, generally referred as media. Storage devices manage the media, right? So there may be different storage devices that are going to manage the material that has been storing over here. So magnetic devices use a magnet, that's why the name given. Optical devices use lasers, right? And solid state devices that will not cover up to the some extent have a physical switches, right? So these are the different storage terminologies. I repeat, media is the material storing data. Then we'll talk about the magnetic devices and we'll also see different optical devices. So let me see, is there any query for students? Yeah, so students, if you have any queries or any basic queries, you can just raise your digital hand and we can have a discussion on that. Otherwise, I can continue with the same lecture slides. Perfect. So let me go ahead and we'll continue. So the first is magnetic storage devices. So it's the most common form of storage, and the examples are hard disk, okay, floppy disk, and tapes. And all magnetic drives work the same concept. Now you can see that this was the image of floppy disk, right? This is floppy disk, what I said earlier with the very beginning. This is one of the image of tape, and you can have hard disk, right? So these devices are nothing but the magnetic storage devices. And I hope that being a computer student or computer science students, you have been very much aware about the functioning, about the hardware terminology of all the devices which have been shown over here. Now let us see the concept. So data storage and retrieval. So media is covered with iron oxide and read write head, right? So we just have this terminology, read and write head. So obviously this this head may read the contents from the tape as well as it may be able to write also. So it's a magnet. Magnet write charges on the media, and these charges may be either 1 or 0. 1 stand for the positive charge and then 0 stand for negative. So magnet reads the charges and the drive converts charges into the binary values. Let me show you in terms of data organization also. So disk must be formatted before use. As you know, we all are aware that once we are going to use the disk, it is needs to be formatted. And based on if you have gone through the subject, operating system, you've also seen that once any memory peripheral system is going to be part of the system hardware part, and OS is going to be the manager of everything. So OS manages everything in terms of clusters, and clusters we say they have been the smallest partition logically that can be understood in terms of operating system perspective. If you have been attending the classes, like in terms of the memory structure, what we have discussed. So I have taught you in terms of operating system perspective as well as computer architecture perspective. So you need to have that kind of, a broad view about both once we are going to, because it's not like that we are going to store only. It's also important that how we are going to access that, because when I said in my first slide now that nowadays having space is not an issue. The main thing is that how you are going to retrieve it, and for that definitely the things are going to be very important. Now you have tracks. So once you perform this, forward draws tracks on the disk, and the tracks is divided into sectors. An amount of data a drive can read that can be in part of sectors. So minimum area, like suppose you have the tracks, inside the tracks you may have the sectors. Now finding data on disk, it means how you will access the data on disk. So each track and sector is labeled. Some are reserved for the user, not users. Some are reserved for the system processes, right? System processes, right? And the system processes may deal with all type of processes which are directly labels to the system programs, right? Some sort of kernels or shells or some sort of compilation issues. So all that may be a reserve. Now we'll see the listing of files, how it has been stored. So file allocation system, which is very famous in Windows, that is FAT32, and network file systems in different other operating systems. So that listing, it's a kind of indexing, right? So we'll know how the file is, where it is being stored. And again, although we'll not cover in that part, as you can see, data is organized in clusters. So again, like from the very beginning, I'm just speaking about this, that you need to see in OS perspective, because then only you will understand that how the data is going to be accessed. So OS perspective and computer architecture perspective. These two things are very important. Let me show you with a very simple example. Like suppose this you have been storing in a hard disk. You have different storage units, like for example, say they are clusters. They are clusters like this. Okay. Now suppose there has been a program. There has been a program P1. Look at this. P1 consists of certain codings. So this code may not fit into a single cluster. Like suppose this cluster has been stored, this program, sorry, has been stored over here. Second, it's stored over here, and then here, and the last one, it takes this 2. So this is my program. This my program fits into this arrangement, right? If you can say it is not on the same fashion that sector and tracks, but simply in terms of cluster, I'm showing that it's work. It has been saved like this one, second, third, fourth, and fifth. Now the thing is that you may be very questioned about how it's going to be mapped. So definitely we require index, and that index can be the FAT or the file allocation table, which index that what are the components, what are the parts of the program, and how it has been stored. And again, this type may depend on different strategies, and it may be some sort of sequential It may be random, it may be hybrid. It totally depends on the structures which we have followed, right? So data is organized in clusters, and the size of data the operating system handles definitely matters in terms of clusters. So coming to the various examples of the magnetic storage devices, we'll just explore because we need to go through the basic that we'll go through the RAD model also, then you will explore the things. And if you wish, we can also have a discussion on the storage part of cloud. So you may have a better feeling that how the things have been changed in terms of storing data from a small, very small unit like floppy disk to the cloud computation. So the floppy disk, right? It's reads with a disk drive, and the rotation, because if we'll show the structure of that, so definitely the data is going to be in a circular fashion. We may have the read write head, and then it can store. So it can spin at 300 RPM and take zero point 0.2 seconds. This has been, the average value based on the simulation results. So it takes 0.2 second to find data. And generally, we have two types of floppy disks: 3.5 inches and 5.5. Right. So 3.5, that is 3.5 floppy disk holds 1.44 MB data. That's it. This was the capacity of the floppy disk storage. So the second and the very famous is hard disk. So hard disk can be considered as the primary storage device in a computer, right? And you have also seen that the growth of hard disk in terms of size. I repeat, when I started seeing computers, I have seen the hard disk of 1 GB, right? 1 GB. And then later on, you may come up with 20, 40. Nowadays, people are working with TB or more than that, terabytes and more than that. So see the exponential growth of storage in terms of hard disk. Now there have been two or more aluminum platters. Each platter has two sides because it's a bidirectional. We can read on both sides. We can store on both sides, and you can see the rotation efficiency. Spin data, this 5400 to 15,000 RPM, and data found in 9.5 millisecond or less, and the device drive capacity greater than 40 GB. Okay, so like saying 40 GB is again less with compared to the current allocation. It has been in terabytes. It has been grown like anything. You can store as you wish, right? And now it is also come where when the concept of cloud has been introduced, so you can use all the resources. You doesn't require to have the hard disk at your doorstep. You just go through and use the services of cloud computing as DASS, SASS, and you can find it out. You can dealing with any amount of data that you wish to be. So this is a typical example of this hard disk, and see it has different tracks, right? And both sides, as earlier says, is readable. And this is a spindle part, where it has been rotated. There's an access arm. Generally, we also say this is in access arm. You may have the read write head, and once you need to read, or once you need to write, so obviously you need to go through that track and the sector. Okay, and until you don't found the track and sector, and that's why you will not get the data. So how to get the track and sector? Again, there are some what I can say, some very important factors in terms of accessing data in hard drives or any of that has been covered in operating system terminology. Like suppose access time. Okay, what is the access time? What is the rotation time? How much time required to get the data? How much time required to average time required to store the, a lot of things related to this. But at this point of time, we understand that these are the different plates, and these platters, they have the magnetic coating, and based on that the capacity of the hard disk can be derived. Okay, now we also have external hard disk that can be covered as removable high capacity disk. So obviously the speed is quite good. Portability of floppy disk, there have been several variants have emerged, and the high capacity floppy disk, which this has been referenced to the previous cases where we store up to 750 MB of data. But nowadays, again, if you can just refer the external hard disk, it comes of terabytes. Now there have been different hard disk examples provide GB of data and it's connected by USB that we have been very familiar of. Third example that I wish to consider over here is tape drives, and that can be taken as part of magnetic storage devices. So tape drives for massive storage, we require the tape drives, and you have also seen that in banks or different organizations where there has been a lot of transactional data, okay, the day-to-day data. So how you are going to store it? So obviously one of the answer is the tape drives. So it best used for infrequently accessed data and the backup solutions, right? Backup solutions, we can use tape drives, and it's a slow sequential access. Capacity exceeds 200 GB or more than that. So this slide shows the data retrieval process. As you can see, there have been electromagnetic plates over here. And once you flow the current, so the bit is organized in form of 0. And there have been some iron particles. So by this way, the direction of disk spins, and based on the contents that has been required, you may again found it out the specific track and sectors. And based on the content, it can be retrieved. Next is the optimal storage. So we come up to this point, CD-ROM, okay, that is compact disk. So in CD-ROM, most software ships on a CD, as we have seen, even if again I reiterate that when we started, downloading, or when we started working with installing any operating system in the earlier days. So practically we started working with CD-ROMs, that what is the efficiency, and you have seen a large growth in terms of sizes also, from where the original CD started and what was the speed and what was the capacity. And you can also see now there have been different variations of CD also. So read using a laser, lands binary 1 or reflect data and pits the scattered data, and written from the inside out, and CD speed is based on the original. So original CD read 150 kbps, and there has been different speeds with reference to this. And if we want 10x, so obviously it's going to be multiplied by this 150, so we can have 1500 kbps. So standard CD holds 650 MB, but students, I again repeat that you may have lots of variations. What I am showing over here, this is just for the reference, because every day or every few days you may come up with a new hardware devices. Same happens with every structured. So DVD-ROM, the next one, that is digital video disc, use both sides of the disk. It's higher in terms of the capacities with compared to the previous CD-ROMs. It can reach 18 GB, and DVD players can read CDs, okay, or DVDs. So you might have the DVD players with you, and you have experienced that how efficiently the things can be managed in terms of DVDs with compared to the previous CD-ROMs. And again, students, I repeat that you may have this kind of stuff, you may have this kind of storage, but again, in previous computers or oldest computers, you require that kind of hardware devices to read or write specifically CD-ROMs and this one. Okay, so again, that was, and it's not going to be very relevant in terms of, because once you port something and you find it out in the second machine, your CD-ROM is not working, or DVD-ROM is not working. So open to failure. They have been very open in terms of getting not reliable, in terms of facing issues, in terms of hardware structure. All that thing very frequently happens. We have the CD recordable also, that create a data or audio CD. Data cannot be changed when it is stored, and can continue adding until full. Okay. You have also might be gone through CDRW, which stand for CD regrettable. So create a reusable CD, cannot be read in all CD players, one of the drawback, and can reuse about 100 times. So again, students, there has been lot of variations. The thing is that something found component in one devices and other it was not working. This happens so frequently because nowadays, you have been working in that era where everything seems to be systematic. Everything seems to be justifiable. In what sense I'm saying this? You come up with a pen drive. You have a pen drive of say 8 GB, right? So pen drive, if you can fit in any of the system with any of the operating system, all the way, if it is not corrupted, it's going to be accessible, right? But this was not true in case of CDs, right? We also have the concept of photo CD. It's developed by Kodak, provides for photo storage. Photos added to CD until full, and original pictures cannot be changed, right? So main option was the image part, right? In terms of image, you can just store the different photo because it is photo storage, and that can be stored in CD up to the extents where you can have. So you can imagine that many of that, when you have a large array of images, so how it can be managed. Like suppose people may move to photo studio, and they will ask for, give me my one of the photos, search for me for which has been captured last 10 years before. So again, you have lots of things, lots of storage, and nowadays again this has been changed. Okay, still you can put the entire thing into a new system and you can find it out on a click of retrieval. Same pattern, we also have the DVD recordable. I will just take a minute, students, just wait because there's so much noise. Okay, fine, now it's fine. So DV recordable, so there are several different formats exist and there is no standardization for that. Allow home users to create DVDs and cannot be read in all types of layers. Even if, like, suppose once you have a DVD, it cannot be play into the previous version of CD-ROMs. Now DVD RAM allow reusing of DVD media and not standardize. Again, the same thing what we have discussed. So this was, students, just a brief overview of all the three types of the storage which we have. So we have gone through the various examples of the first one, that magnetic optimal, and we'll soon discuss the third one, that is the RAID model. And you can, if you are just referring the e-contents which has been provided to you, you can also see that we need to discuss about the connection of IO devices to CPU or memory. There's a very important part, and all the way, because we are going through the computer architecture perspective. So you must be very clear about what is interface, how it connects, and what are different devices. Right. So this diagram shows the connection of input-output buses to input-output devices. So for an example, suppose there have been the IO buses which are shown over here, that the first one is the data bus, second is the address bus, and third is the control bus. Okay. So this has been connected with the processor, the CPU. And if you are going to have the keyboard and display terminal or printer or magnetic discs or magnetic tape, any of the devices which may be used for input or as output devices, then you require an interface. And earlier days, we used to say this kind of interface maybe known as what? Maybe known as device drivers. Just give me a minute. There is some noise over here. I will just reconnect. Okay, just wait for a moment. Okay, so sorry for the inconvenience. I think now the things are quite okay. So I was just talking about this, that if you have any peripheral devices, for example, these are peripheral devices. They have been connected by through CPU by different, the data lines, the input output buses that may be defined as data, address or control buses. And there has been interface. So I was just speaking about that interface itself. In earlier days, when you need to have any peripheral devices attached to the system, you require the device driver. Okay? Device drivers, because nowadays device drivers, they are inbuilt in the OS itself. If you come up with the new devices, like suppose I have just brought a XP pen, so definitely that the device driver has been embedded. So many of the things happens that, but in earlier days when we need to have any devices, we need to download, we need to install the device driver, then only the system will cope up with that, right? So let us see what is the interface and how it works. So interface may have different kinds of commands, and the different kinds of commands are control, number one. Second is status, and we'll see about the data output and the data input. Let us explore all these things. So in case of the control, once we have this command of interface, so we give a control command to activate the peripheral, right? And this can be done through the control buses. So a control command relies on peripheral, and every peripheral obtains its own differentiated series of commands according to the operation mode. What I said, that in case of device drivers, you come up with a specific set of instructions that may be required to control that devices. So same that control devices, same that control commands be very specific to each and every element or to each and every peripherals that we are going to work with. The second is status. Okay, that has been the first one. Second is status. So this command is used for testing different condition of status in peripheral as well as interface, right? So for example, like before initiating a transfer, the computer may want to verify the peripheral status, right? When the transfer is going on, some errors may take place. These errors are observed by interface. So very important thing, because if there has been a transfer from any of that devices to that part, to that peripheral, so before that, before initiating the things, we need to have a control status. What's the status of that? And based on the marking, as you know, you people might be have gone through the semaphore working, that 0 and 1 status. So 0 means that the variable is free, and 1 means the variable is occupied by some other transactional processes. Or the same terminology, we can have a binary bit which specify clearly what is the status bit of that peripheral. We also deal with data output. So in this command, the interface responds by transmitting data, right? So data is transmitted from bus into any of its registers. So as you can see that, for example, consider tape unit. So by means of control command, the computer may begin the tape moving. So then the status of tape is monitored by processors, and this is done by the use status command, which we have like just discussed before. And the data input, so obviously it means this is the interface which obtains a data item from peripheral, right? So this data item is placed in buffer registers of interface, and the availability of data is checked by the processors. So obviously again we will look after the status command, and then the data input command is issued. So the interface puts the data on data lines, and also the get data accepted by the processors. So let me go back and show you that whatever we have shown over here, like all that 4 commands, which may be status, which is status, control, data in, or data out, right? So they may be, the interface logically has the controls, have the signals with this IO buses, that what is the current status, what's the command needs to be given in terms of control, and whether we are going to take the data or whether we are outputting the data from this devices, from these peripherals. As you can see, this is again example of IO interface unit, and we have just talk about, okay, the different the all that status of the commands. So suppose if you have this port A register, so that may be IO data, or second again input or output data. One of the status registers may deal with the status part. Second maybe deal with the control, that is control registers. And these are the buses, the internal buses that deals with the bidirectional thing, that bus buffers. Now, if you can see this interface, because interface is going to work with the IO devices. Second time, there may be IO devices and there may be CPUs, right? CPU, one processor. So as you can see, there have been different combinations, and this combination itself mimic what the behavior of the current scenario of interface is. For an example, if you have like suppose 0 cross cross, so data bus in high impedance. And if you are just using 100, it means port A register. This one is going to be active. If you have 101, so port B register. If it is 110, it is control register, right? Where one stand for this control status and RS1 and RS0 stand for different, register select. And the status register, if it is 111. So based on the values, you can just see that somehow the interface works. One of the way is CPU, where different registers has been attached in terms of the timing and control unit. There have been buffers, and the right side there may be different commands which is issued through that using the different control as well as status registers. Now the very important part about where we have like started, that what about the performance, right? And this point I need to deal with on extension, that you must have a thought on this, because just going through the previous example, I was really worried that this is a very basic thing. Okay, and the basics, I think at this level you might have so much exposure of this thing, but because of the syllabus, because of the content, I was supposed to cover everything. So that's why in a very short, I have just gone through the basics of the storage. I might think about this, that you people may understand what are the different terminologies related to the magnetic tape, magnetic disk, as well as the different storage structures. That was quite easy. And if you have just referred the previous videos in terms, if with reference to operating system also, we have discussed many more things. Now, as far as the quality structure, as far as the performance improvement, let us see the three major things which are going to be at the soul of discussing with the structures. First is reliability, number one. Second is availability, and third is dependability. And if you can refer the e-contents provided to you, you can also see that reliability is anything broken. Is it reliable? Is it going to be work now? No. So, and the second is availability. Is the system still available to the users? Very important point, right? Is it going to be available all the time? Is it 24/7 available or not? That's because if you can see the one of the example of the banking scenario. Okay, so you just might think about that obviously the secondary storage is very important. What will happen if there is any flaw? What will happen if there is any disaster? Okay, how the things has been stored, how the things has been captured. These are the very important issues, because nowadays we may have day-to-day transactions. We may have tons of transactions per day, lakhs of transactions per day. But ultimately the things matter is that whether the durability property has been satisfied or not. What is durability? It means that if the transaction has been successful, whether we are in the mode that everything is successful, has been stored properly or not. This is a very important thing. And the next is dependability. Is it worth to trust the system, right? That is the next point. So coming to this, response time and throughput are given considerable attention while processor designing. Reliability is given more attention in storage than processors. Now the terms reliability, availability, and dependability are often confused with each other. Let us be very clear about this based on the questions. But before that, I will also talk about the response time, because this has been one of the major criteria also. So response time means when I get starting the responses from the system. Okay, the first response, right? The first response I am getting. For example, like suppose there's a user, and user just thrown a query. This is a query, and this has been submitted to the system. Okay, this has been submitted to the system, and it may possible that after some time the first response in terms of its query, after say 5 seconds. That is the response time. And after that, suppose I'm getting so many responses. But what is the first response time? What is the first response when you get? That is the response time. This particularly very understandable when you read about the CPU scheduling algorithms, right? Suppose for an example, if you are FCFS, first come first serve, what happens? Suppose there has been a process P1 which arrives, the arrival time in the system is 0. Okay, so it means it is ready to execute, but there is some other process executing by CPU. So this arrival time, this process P1 gets started by say 11, right? After 11 seconds. So that will be the first response time. There are so many examples. And the second point is throughput. The throughput is how many number of process executed per unit of time, right? How many number of processes executed per unit of time, that is throughput. And again, it's a very important criteria in terms of this storage system also. Now, we need to be very particular. Reliability. What about this? If anything gets cracked or broke, what will happen? Availability, is it going to be up all the time to the users? And dependability, is it trustworthy or not? Is it worth to trust the system? So you just have a thought about this. Like when you're dealing with storage system, when you're dealing, you have been given the job of creating a storage structure of a big organization that is very reliant to the day-to-day issues, okay, day-to-day transactions. How you are going to have a system which is trustworthy, which is a high availability, and what about like the reliability should be there. Even if there has been a massive cracks, massive issues with the system, still it should be able to replicate the data in an efficient manner, that there should be no loss of things, right? Because once we start working with any structure, we should be very particular about number of things. And if you have been gone through the software terminology, we always have a reference models. So same with, if it is okay with software, also try to have the impact in terms of hardware also, because ultimately at the core of everything there is the hardware structure. So now I come to the next point. I think the time is fine. We can go it. So how to use on this multiple disk, and we have been discussing about various issues. And even if from I have been teaching so DBMS also in previous courses, so I always used to take, when there has been a the structure of storage issue comes, definitely we need to deal with the RAID model also, because ultimately either you're working with the normal storage system or you're working with database storage system, ultimately is the data where is going to be reliable. So multiple disk, if you have the multiple disk, we have discussion on reliability, the performance issues, and we need to take consider both also, that the system should be reliable as well as performance should be high. So we come up with this system that is known as a redundant array of inexpensive disk. I repeat, it is redundant arrays of inexpensive disk, that is the RAID model, and which combines the features of stripping as well as mirroring. Now, if you can see, the first part, a system depending on N disk, right? A system depending on N disk is much more likely to fail than one depending on one disk, right? A system, I repeat, depending on N disk is much more likely to fail than one depending on one disk. If the probability of one disk to fail is F, then the probability of N disk to fail is 1 minus the failure coefficient 1 minus F to the power N. Now, if you have just thought about this disk stripping, right? So it is what the process of dividing a body of data into blocks and spreading the data blocks across multiple storage devices, right? So this is how the reliability and the performance can be come up together using the concept of this. When we started with RAID 0 model, that was generally known as disk stripping. And I repeat again, this stripping means that process of dividing a body of data into blocks and spreading the data blocks across multiple storage devices. Now you have been like, if you have some earlier courses or if you have seen in DBMS also, that stripping and mirroring, they have been at the core of RAID model. So stripping means splitting the flow of data into blocks, just now I said, of a certain size, and this size is known as what? Block size. then writing of this block across the RAID one by one. So this way, the data storage affects the performance. And what is mirroring? It is a storage technique in which the identical copies, right? As you can say from this word itself, where we can have the identical copies of data are stored on the RAID members simultaneously, right? So stripping is that dividing and storing, and mirroring is we are going to store the identical copies. And you can also see that there have been a lot of changes, a lot of extensions to this RAID model, because we come up now, we are dealing with RAID 2, RAID 3, RAID 4, and other things also. So as we'll try to do that, and we'll try to understand that the main concept of all these things. So this is a very easy, figure or image which talk about data. It can be stripped to, this first one and the second. So it is stripping. And if, as obviously on that case, it has been split, the name given, and divided to the other blocks, and it has been stored like this. And if you can go to RAID level 1, so this stands for the mirroring. And the mirroring is that the identical copies, like suppose I may have a data, so the identical copies has been stored over here. Identical copies can be stored. We also move to RAID level 2. That will be, although quite in terms of changes like data. So we just go for the bit interleaving structure, and then it can be changed into the data bits as well as the check bits. The things, if you can compare, still there has been different questions that what about RAID 0 and RAID 5? Can you compare in terms of performance? So yes, I still say that I cannot say that if it is RAID level 5, it's always going to be winner. It's always going to be efficient. It's always going to be performance high in all structures. No, there have been different issues, different parameters, different attributes where we need to consider about this structure. So in case of RAID level 3, there is a bit interleaving parity check bits. And again, the structure is like the same. We have the data bits and we have the parity bits for checking the system. In this RAID level 4, the things has been changed in terms of block, right? So block interleaving parity, where it has been divided into, the storage has been divided into this, I can say, data blocks as well as the parity blocks. And if I can show you this RAID level 5, where data and parity blocks has been merged. So RAID 5 is disk stripping with parity, right? I can say like this. The other name is that RAID level 5, it is disk stripping with parity. And what is it? It means with this level of RAID, data is stripped across 3 or more disks with parity information stored across multiple disks, as you can see from this image itself. And parity is calculated value that's used to restore data from the other drives if one of the drives in the set fails, right? So this there are some uses of the parity bits that can be shown. I'm not going to the detail of everything, that how the parity bit influence the storage, how the designated blocks or servers can be assigned based on the parity checks. But still, you can just see the different structure what we have shown through. Again, I repeat that if you can just check with RAID level 0, where the data components has been stripped, has been divided, has been split into multiple destinations. RAID level 1, we have mirrored and we keep the identical copies in different locations. We started bit level interleaving in terms of data for data and check bits. Then we introduced the concept of parity bits in RAID level 3. RAID level 4 comes to the block interleaving, right? So we have a bigger component of the data that can be checked, that can be stored in terms of the parity bits. So same with the accessing also. And the last is RAID level 5 that we have discussed in terms of data and parity can be. Although obviously you can say the stripping is there, the data has been divided into multiple blocks, but still you can say the parity bits are also available, so we can find it out at what extent of the data has been stored in the distributed environment. So these are few questions I have referred to. What if we have a lot of small writes? There are a few questions. So RAID 5 is better if we have so many small writes. And what if we have mostly large writes? So multiple of strips. and either is fine. Okay, so these are the few questions again, because I said earlier that as far as the performance issue is concerned, we cannot rely and we cannot conclude that if it is a higher version, it's always going to satisfy all that constraints. So it depends on the behavior, it depends on the data, it also depends what kind of structures that you may be relying on, because ultimately the three issues that we have discussed is always going to be considered for that. What if we want to expand the number of disks? So RAID 5, add a disk, recompute parity, and shuffle data blocks among all disks to establish the check block pattern. And in the bracket, you can see it's not going to be an easy job, because once you do all that things, it's going to be expensive. So this is a few understanding of RAID 4 versus RAID 5. You can always refer the e-contents which has been provided to you to have more depth and more understanding of the contents which we have discussed. And still, I just leave this question to you, that if you have been given two options, that if you have to store a data bit in RAID 0 as well as RAID 5, so which one to select and which one is not to select? Again, I just leave this question to you all to have a thing, so you may be understanding that. And again, I repeat that we are not going through the entire structure of this. This is a brief overview of how the structure places, right, in terms of memory. If you want me to go through in depth how what is the structure of RAID and how the things are work, what I've shown you in the previous content, so definitely please log on into the SLM and just give me some queries. Just give your concerns that you want some explanation on the RAID model also. So obviously that can be considered for the subsequent sessions. So beyond disk, we have now a concept known as flash memory. So it's used for the different storage, and obviously the database storage. It's writable also, readable also. Writing is slower than reading, and it's obviously flash memory is non-volatile. It's faster than disk, but slower than the dynamic RAM methods. So it has the random access, but limited lifetime, and it's more expensive than disk. So we have a lot of things, lot of options nowadays, because when I started my session, you have heard about that the things has been changed like anything, from where we are using the 1.4 that memory. So it comes to where flash memory, where itself is an electronic, you can say non-volatile computer memory, which has different medium to be stored and reprogrammed also. So things has been changed drastically. And there is a part of disk. Obviously, we have discussed the system store data in disk. They provide so many things, and the I/O time dominates for this. And the major concern in terms of OS perspective also is the seek time, okay, and the rotational delays time. Because if the seek time is going to be on a higher pattern, the things are not going to be accessible, and we cannot say it's an efficient mechanism for storage. So this disk, what we discussed earlier, to achieve redundancy and concurrency, we can apply the RAID models, which started from 0 to 5. And to achieve only redundancy, we can do mirroring. But to achieve concurrency, we can do stripping as well, because all the way we require systems that should work in a network environment, that should work in a distributed environment, and that should be readily available. So these are few points, few what I can say trigger points that you may please refer once defining storage structures, and find it out what is the storage I am using and how, on what basis it is optimized in terms of the different reference points. So I think we come to the conclusion of this session. And in this unit, we have discussed about the storage system. We have defined that in computer perspective. We have also discussed about the storage devices such as magnetic. In various examples that we have covered, we have also seen the process of interconnection between I/O devices and CPU memory through the interface part. We have also discussed about the reliability, availability, and dependability of storage systems. And in a brief overview, we have talked about the RAID system, and we have discussed what are the different performance measures. I hope you got the basic terminologies and basic idea of the different storage structures. This is a session which may have triggers to multiple other sessions where you can pick any topic, and that may lead to have more in depth, more and more in depth. So I recommend that if you're interested to have more understanding, you may refer the contents which has been provided to you, and you can also refer some very good books on the subject matter. So with this, I thank to all the learners. Thank you so much.
Thank you, sir. If
Yeah,
learners
thank you.
can have any query, then they can ask.
Yes, so I just give the control to Ravi Ranjanji. Ravi, yes, you can come up and please ask your question.
First of all, sir, happy Teachers' Day, sir.
Thank you, Ravi. Thanks to you, and thanks to all of you for being here, and happy Teachers' Day to each one of you, those who is present over here.
Sir, my question is, recently we see that RAID technology is based on our server, sir. Basically, we are
Yes,
using in organization, we create RAID. But
yes,
sir, can we implement RAID technology in our normal system?
yeah. It is basically server model.
Okay.
Yeah.
So in normal PC, we cannot implement RAID
Yeah,
technology.
actually, Raviji, we have not covered the part of direct memory access DMA model. So in DMA model, when the control of CPU or through the CPU, we directly access the secondary memory. Okay, this is
Yes,
just
sir.
a replica where you have heard about the demand paging system or something like that. The entire secondary memory, which is about 20 GB or 80 GB or something like that, that can be reciprocally converted to as a RAM, or otherwise I can say RAM behave as the entire size of secondary memory. So that concept we have missed out. It's not a part of our curriculum. So, but still we have a lot of option other than RAID also in our own systems.
Okay, okay. Thank you, sir. Thank you.
Yeah, yeah. Yes, Sudhirji, I will just give the chance. Okay. Yes, Sudhirji, you can unmute and you can start speaking.
Thank you, sir.
Yeah.
Computer architecture has changed drastically
Yes.
once Patterson and Hennessy wrote their first editions of the book. These days, in addition to CPU, we use GPU SmartNIC for programming. We also
Yes.
use storage class memory for as a replacement for secondary storage. This is
Yes.
my question, sir. Actually, don't you think that many universities in India need to revisit their computer architecture syllabus? And my second
Okay.
question: do we
Yeah.
have the same syllabus for us? Is the syllabus in Manipal University same for regular courses as ours?
See, actually, as for the syllabus or curriculum is concerned, I do agree with your first point that we need to upgrade as per the requirement. And yes, because this is the first time the courses has been introduced and offered, so definitely I think they have some specific period of time where the course structured and curriculum everything is going to be revised. So that thing is very frequent, because being a part of the university, Manipal University, I do understand the process. So it might be like you may come up with some other recent features very soon on that topic.
Thank you, sir. I was not referring to Manipal University and
Yeah,
alone.
yeah, yeah.
Syllabus is more or less same actually in other
Yes, yes,
universities.
yes. But Sudhirji, there is a point. The point is that, like, suppose we can what you said, that there has been different inventions, different extension in the CPU. But until and unless students will not be understand the basic of everything, the core of everything, like what are the buses that are used for control data and other things. So how come we can migrate to the other things? So that's why teaching through the basic terminology level is recommended for something which is at the beginner levels.
So this is an undergrad. It's not an undergraduate course, right? So
Yeah,
that's
yeah,
the
yeah.
point.
Yes, yes, you're right. You're right. Say.
Thank you, sir.
Yeah, thank you. Okay. Yes, Sakshi, you can speak out. Sakshi Gupta, you can unmute and you can speak out your question. Yes, Raju Prasad.
Sir, what is the difference between software RAID and hardware RAID?
Yeah, can you repeat?
What is the difference between software RAID and hardware RAID?
Software and hardware RAID. Okay,
Yes.
so you just wait for the next session where we are going to explore the different structures of RAID. For that, you need to wait for the next session.
Okay. Sir,
Yeah.
one more thing, can you please explain about NL size type of hard disk?
Can you write the question in the chat window, please? Because we have planned this is the first session that we had in for solar system, and during my session also I said that we are going to explore much more on the RAID model. So all that components of RAID and all the different types of RAID will be discussed separately. Now coming to Rakshit.
Good afternoon, sir.
Yeah, good afternoon, Rakshit.
Sir, can you tell me what is the main purpose of using RAID model?
Okay, so main purpose, as you have seen in the presentation itself, is all about the performance issues. Like suppose let me go through. How we can have reliability as well as performance. That's the main issues. And see if you are going to work on a server side, if you are going to replicate the data, so how the things are going to be managed, that is the main purpose. Because if I can talk about that I'm working in a workstation, like suppose in first case I'm having a workstation, I'm having a host system, so can we go through the RAID system? Is it justifiable? Did you got the answer?
Sorry, sir. Can you
See,
repeat your
actually,
question?
I'm saying that, like suppose when you require a large array of memory, and if you're going to work on the server side, if you're going to work on a large pool of data, then we can justify the use of RAID.
Okay.
Yeah.
Hello.
And also, yes, there are some other, elementary requirements in terms of performance also, because as I said that we have lots of things in terms of memory and optimal memory systems, but as far as the performance is concerned, definitely as because you have been going through, the advanced database courses, and even if there also you have seen that if there has been a memory unit issues or memory storage issues, then definitely one of the option is RAID. So we'll come to that point. I think you need to wait for a session where next session we are going to discuss about the different architectural perspective of RAID level. Then you will understand the different other aspects also.
Okay, sir. Thank you.
Yeah, yeah, sure.
Hello.
Yes.
Hello, sir. Good afternoon, sir.
Good afternoon.
Sir, happy Teachers' Day.
Yeah, yeah. Thank you, Vita. Thank you.
Sir, I wanted to ask that now you said that stripping and mirroring needs to be applied for both redundancy and concurrency.
Yes.
So for redundancy control, are both the process compulsory or only stripping?
It's
And means
not
like in
compulsory. It's not compulsory. It totally depends. See, when we started working with RAID, okay. So first
yes,
option was that we can do the stripping, and stripping is again being very intellectually okay, working with the data and dividing and sharing among multiple instances. That was stripping. But stripping is not always going to work effectively. Somewhere we require that we need to have identical copies, so we need to go for mirroring.
mirroring. Okay. And for same for concurrency also, sir.
Yeah, yeah, concurrency. See, actually, you just have a thought on concurrency that how come we can achieve the concurrent system? How can we can come up with a variable and that variable may be allocated to multiple transactions? And how come that transactions may be without conflict free? So obviously, if we keep the multiple copies of that data into different servers, so it will create a lot of hurdles. Every time we need to have an interface, we need to have a logic that how come what's the current status of the data and what is the current value. So in that case, stripping is more preferable.
Okay, sir.
So I thank each one of you, and I do recommend that you may please have a go through on the RAID, but in the subsequent sessions, we'll see the operating system perspective as well as the hardware perspective of the RAID label in much more detail. Thank you.
Thank you, sir, and thank you, everyone. If you still have any doubt, you can post it over the discussion board. Have a nice day.
Thank you.